Hello there, good morning. Now, for today, I want to actually look at integration. Now, that's mathematical integration, okay? And what I want to actually do is to show you how I approach it for myself. Now, I hope that you will find this useful in one form or another. But before I do that, what I want to do is to say hi to my granddaughters. One, Elisa. Two, Natalie. Three, Corinne. And Olivier. Now, I think it is Olivier or Oliver. Let's just call her Ollie for short, okay? Right. But they are pleasant to be with, and I enjoy them tremendously. And I enjoy their company at all stages. And I have to consider myself a little bit fortunate because when I'm in their presence, they make me feel good. Okay? But anyway, girls, hi from Granddad. Right, let's get to work. And what I want to look at mainly now, again, is integration. So excuse me for a second while I bring this online, okay? Now bear with me while I try to make sure that this process can be followed, okay? Now that looks good to me on my screen, okay? Now here, integration, okay? Now mathematical integration, okay? It's not does not refer to integration of any other sort. Now the process of integration. Now what I want to look at is the process of integration reverse the process of differentiation. Now differentiation, a mathematical differentiation is something I'm going to be looking at also. But in differentiation, if f x equals 2x squared, then f dash x equals 4x. Now, how did I get this? Now, we multiply the whole number 2 by the square of x. Therefore, 2 times 2 would be 4 equals 4x. Now, that's the way I have approached it in order to try to show a method that may work for some individuals who may not grasp the concept of it directly, okay? Now, just the integrated of 4x is 2x squared. Now, remember, integration is the process of moving from f dash, now I call this f dash x, to fx. By similar reasoning, the integral of 2t is t squared. That is like saying t times t equals t squared. But the only difference here, you would be simply saying that you're multiplying letters rather than numbers. So it's worthwhile keeping that in mind. Okay. Sorry about that. 1 second. Let me just get a little bit organized here. Okay. And I'll try and bring the whole thing in now for you fully as a complete scan. Okay. Bear with me for a second. Thank you. Okay. Now you need to write this out for yourselves. You cannot just assume that you're going to look at this and understand it. You have to write out the process. You have to do some additional research. Now, the gentleman's books I use is again a guy called John Bird. He does some excellent engineering mathematics. Okay, and I've used his work. Now, this is page 1. Okay. So let's just turn over a second here. Okay. And again, now I'm continuing with integration process. Now, integration is a process of summation or adding parts together and an elongated symbol. Now, this elongated symbol is what we use to tell us that we're actually doing a process of summation in respect of integration. Now, this symbol is used to replace the word integral. So once you say that symbol, you know you're already in that process of integration. Hence, from work done above, 4x equals 2x squared and 2t equals t squared. Now, you would have seen that from prior information that I've just done. Okay, but again, you need to make the write out for yourselves and understand the concepts. Do additional research, okay, so you understand what's been said and what's been done and what you have been provided with. Okay, mathematics is something that you have to get practice to acquire a precise understanding. Okay, and that is page 2. Okay. Now here, what I've done is to go into looking at the general solution of integrals of the form ax to the n. The general solution, let me make sure it's on screen. Okay, 1 second. Okay. General solution of integral of the form ax to the n dx, where a and n are constants, is given by integration symbol ax to the n dx equals ax to the n plus 1 over n plus 1. Now, plus c. Now, c is to be a constant, so it can be a constant in any stage or any given value. Okay. But remember, this would be the application that you'll need to apply in regards to integrals of this format. Okay. Now remember, this is a rule, and this rule is true when n is fractional, 0, or positive or negative integer, with the exception of n equals 1. Now again, quite a number of you will be familiar with this because you have done a lot of this at school. But if you haven't taken it in at school, then you need to be taking it in now, especially if you're going to be engineers. Okay. Using this rule gives 3x to the 4, dx equals 3x, 4 plus 1 over 4 plus 1 plus c. Ignore my mess there, okay? Because it was just to show that it's plus c, wasn't c over 4 plus 1. Okay? Now we've applied this formula to this stage here, okay? Which equals, taking 4 plus 1 gives us 3x to the 5 over 4 plus 1, 3x to the 5 over 5 plus c, okay? And c can be any constant. Now looking at 2 over x squared dx equals 2x to the minus 2 dx equals 2x minus 2 plus 1 over minus 2 plus 1. Again, here we're looking at, again, a given example. Remember, these are only examples. You will need to apply them when you come to do your own calculations in regards to your maths lessons. Now, I know some of you guys can do this in your head. Brilliant, okay? But one of the things that I found was that when I asked a person to say, well, look, how did you get a solution of this type? He did it in his head, but he was unable to write it down to show me how he did it. Now, one of the things you now need to be able to do is to show your working out, to make sure that the work is yours and not someone else's. Okay? And it also avoids the claim against anyone making a claim that you simply copied it from someone else and you did not use it for yourself or create it for yourselves. Okay. So sorry about that. Moving about a bit here. Okay. Right. Let's move over. Turn over the page. Hang on. Let me just go back, go out a bit, pan out a bit, so you can get this fully in. Okay. Okay. Turning over now. Now, what we're going to see is how this has been applied in the next page. Okay. Now, remember, you have to write out the information for yourselves. You have to make the work your own. Okay. There's no shortcut to it in any shape or form. Sorry, 1 second. Bear with me for a second. Okay, one second. Bear with me for a second. It's okay. Bear with me for a second. 1 second. 4. Okay, apologies for that. It's just I had everything sorted out. Thought I had, but for whatever reason, it did not quite run the way I expected it to run. So, 1 second. Yes. Okay. Now it would seem like I've missed something out, but it's okay. I can see what I've done now. Okay. From the previous work that I just did. Sorry, let me just get this all in. Okay. If we go back to this just a moment here, and we're looking at this bit here. Okay. Let me just take it out a bit. Okay. You can then see that -2 + 1 becomes a -1. Okay. And that a -2 would then leave us -1 at this stage here as well. Okay. So we end up with 2x to the -1 over -1 plus c, which is your constant. Okay. Which is equal to -2 over x plus c. Now, to get to the final solution, we have to multiply out and cancel down. It is a process you will need to practice. Okay. Now, remember, this is only one way of looking at it. There are different ways also, but do some research for yourselves. Some of you will do this in your head automatically, but the problem will come when you need to write it down on paper to make sure that you can understand it. Okay. Now here we have another example. Remember that dx indicates rate of change. Excuse me. Okay. And here we have an example here. So let me make sure I get this in. Okay. Now, some processes here is automatic. You just do it automatically, okay, in your head, and you know the result is there. Yeah. Now here, square root of x in respect of dx. And here we have integration. Again, looking at integration still. We have x equals to the half, dx equals x to the half plus 1 equals 3. Now, for me, I've simply taken a view here, make a note here for myself that I multiply that by that, which gives me this result here. Okay. Now, this result here comes from a formula which is given in your original research information. Now, you need to get familiar with this because when you're dealing with this, this will always come into play. And here you have plus c. Okay. Here, this process of 3 again, I've simply applied this method for myself. Now, this is just trying to show how the values might have been achieved using an alternative method. Okay. And just a note for myself here, this is saying to me 2/3 of the square root of x cubed. That's what that is saying to me overall. Okay. Now, when you're dealing integration and differentiation, you have to get used to the given formulas and the rules that applies. So get practicing on the rules. Now, I will bring the rules into play and show you the rules a little bit later on. But I know some of you guys are quite au fait with integration and differentiation. Some of you might have got A-level mathematics. Okay. But the thing is, some of those guys may not always, and girls may not always have that advantage. Okay, excuse me a second. Now here, what I want to look at is in reference to the previous work which has been done, each of the previous 3 results can be checked by using differentiation. The integral of a constant k is kx plus c. For example, 8 dx equals 8x plus c, okay? And it tells me here to go to 6. Now, that is from, in my case, for page 6. Okay, let's see if I can make this any simpler and show you how it's done more applicable. And again, we're still dealing with integration or integrals, okay? All right, let's get to this now, okay? Sorry about that. When a sum of several terms is integrated, the result is the sum of the integrals of the separate terms. Now, what is simply saying there is that you're adding all the separate terms together. It doesn't matter whether it is several, 10, 20, or whatever, but all those terms will be treated as a separate term, and the end result of those terms will then be added to give you your final solution. For example, 3x plus 2x squared minus 5 dx equals 3x dx plus 2x squared. Now, you'll notice that we've taken each term and given it its own identity. Okay? For the want of a better word, I will call it identity. Okay. Now, this gives us 3x squared over 2 plus 2x to the cube over 3 minus 5x plus c. How did we get these? The integral of x is x squared over 2. This then becomes 3x squared over 2. You're going to see why this has become this, okay? By applying the rule, okay? The integral of x squared is x to the cube over 3. This then becomes 2x to the cube over 3, okay? Okay, let me just go back a little bit and I'll bring it fully in, okay? Sorry about that. Okay. This then becomes 2x to the cube over 3. That is how we arrive at our results. So we know by conclusion that that process would be applicable because we have used the rule. Okay, thank you. Well, I'll stop there for now, but again, look at the information, write it out, okay? Make it your own, okay? Look at how the rules are being used and how they apply, and you'll find that in regards to integration, once you understand the rules, you can manage and handle integration. Okay, I'm going to stop there for now, and I hope you have found this useful. Okay. So for now, thank you. Have a good day.